Okay, welcome to video class number 2. So we are going to start with some of the terminologies associated with the control system. So for to study the terminology associated with a control system, let us consider a general closed loop system. Okay, so here is a block diagram of a simple control system which controls, say, a plant. Plant means a chemical plant or whatever it is. Say it can be a boiler in a plant. So that means in a boiler, of course, the temperature, pressure, everything has to be controlled. So it is just a general block diagram of a closed loop system. Now, as in the previous video, we have seen that there are two types of control system, that is an open loop control system and a closed loop control system. And the major difference is in a closed loop system you have a feedback, and if you are considering without this feedback, then this represents an open loop control system. So from this we are going to study the general aspect of or general terminologies that comes or that's associated with a control system. Now to start with, every time control system refers to controlling of something. So here this is going to control plant, or this block is sometimes called as a process. So I think that will give you a much more idea. That is to control a process. So for example, in a chemical factory, if a boiler, a boiler which is working at a very high temperature, so it should be kept in a remote place, but that has to be controlled. So that's why this is plant or process, and this is the major focus of any control system, and this is the thing which is to be controlled, right? Now then the output of this is to be monitored, right? So this output we call as the controlled output. Controlled output, initially we simply assume the output of that plant is in control because it's just started, so no problem, so it's controlled. Now this controlled output, what happens is this controlled output is fed back, and it is to be compared with the summing point. This is we usually call as the summing point, or this is what is called as the error detector. So what it does is at this point the feedback signal is compared with the reference input, right? So this I have mentioned in the previous video. That is, a control system always controls the output so as to get its desired value, and this desired value is given as the reference input, or it is sometimes called as the set point. So the reference input we give to the system, which is called as the input, is called as a set point, and usually that is represented by the letter R of t. R of t refers to a time domain signal, or this is the set point or the reference input. Okay, this is the reference input. Now this is then combined with this a feedback signal. Now why this is plus and minus? That is, this refers to the type of feedback. And as you know that there are two types of feedback, that is, it can be either positive or a negative feedback. Okay, now if it is a positive feedback, then this is plus. If it is a negative feedback, this is negative. So this acts as a summer. That means it takes the sum of R of t and the signal that comes over here. So let us call this signal as the signal which is fed back as B. Okay. So what will be this signal? The signal that comes at this point. This will be either R of t plus B or R of t minus B. So this is, you can write this as R of t plus or minus B. Hope you are following me. Okay. Now, this is what is called as, what is this called? This is actually the error, right? This is called as an error. That is the difference between the set point and the feedback signal. So what is the objective of any control system? So the objective of any control system is to make the output to be equal to the reference input. That means you are expecting a zero error at the output for a controlled output. So whenever the output is in control, we can see that the error signal has to be zero. So what must be the primary objective of control system? The primary objective of especially a closed loop control system is to minimize the error, or is to make this error signal to zero. Is it clear? Now, this one is the feed forward element, and so the feed forward elements are the components of the forward path that generate the control signal U. So this generates the control signal. This one generates the control signal. Which one? The feed forward element generates the control signal so as to control this plant, thereby getting the controlled output. Okay, is it clear? Now, this feed forward element is also called as feed forward element is also called as the controller. Is also called as a controller, which actually bring about this control action into play. Okay. Okay. Now, one more point is there, that is in the plant or in the process, you can have an external output which is called as a disturbance. This represents the external disturbance that can cause the output of this plant. Okay, so say outside temperature, or outside any parameters that can cause a change in this plant or process, the external to this plant. So that is called as a disturbance. Now, if there is a disturbance in the plant also, the controlled output gets varied. So what happens? This will be fed back and be compared. And suppose, imagine that initially it is controlled and suddenly a disturbance came. Okay, suppose that external temperature increases, just imagine, and that in some way it disturbs the plant. So that means the controlled output is no longer a controlled output. That means there will be some feedback element, there will be some amount of B, and what happens, and because of the presence of B, there will be an error signal at the output. The error signal is no longer going to be zero. This actually induces this feed forward element to generate a control signal, so that by using that control signal, the plant gets controlled in order to maintain this set point. That is the basic working of a control system. Now, what will happen if you don't have this feedback? If you don't have this feedback, then that becomes an open loop system. So that open loop system will be having no reference point. Okay, so when you take away this feedback, what you're going to get is, you're going to get two blocks, right? One is, say, let us call it as the controller. This is plant. Okay, using the plant, the output. Here is the desired value. The controller then to reference input, and the controller giving to the plant. There is no feedback. Now, what is the drawback of this? From this itself you can see the drawback. Now, what if some disturbance happens to this? So imagine that some disturbance is caused here. Similar to this case, there is no mechanism to feedback this. That means the output will change. There is no mechanism to control here. Okay, so manual control is possible, that's all. but there is no automatic control or a feedback system existing. So once if it is disturbed, that is disturbed, the output gets distorted. Okay, but in the last video I have mentioned some of the advantages of an open loop system, and the major advantage is it is never going to be an unstable system. But what about this? Because of this presence of feedback, we have studied especially the positive feedback can make the system oscillate. Now, if a particular system oscillate, then we say that now for a control system, it is important the system has to maintain a control output at the set point. Now, if this is fluctuating or if this is not stable, that means the output gets fluctuated, and that is not at all desired for a control system. So, such a control system we call as an unstable system. So, there must be some mechanism to nullify that effect. Otherwise, this is going to be a worst impact. This is going to make a worst impact on such control system with feedback. But fortunately, we have number of methods to make even though there is a presence of feedback, we can make the system to be in control. Okay, now one more thing. This error signal is also called as the actuating signal. Error signal is also called as an actuating signal, and there is a correction. As I told you about this disturbance, I just by mistake I mentioned it as output. It's not output, it's an input. Okay, you can just understand that because the arrow is shown into. So disturbance can be any external change that can cause the change in the output of the plant. So a closed loop control system, there is because of the feedback mechanism, even though there is it changes the output, that output will gradually gets into control because of this feedback. But there is no such mechanism in an open loop control system. Okay. Now, next term is forward path. Forward path. Now, what is this forward path? Forward path is the transmission path. The transmission refers to the transmission of the signal. I will explain that. Transmission path from the summing point, to the controlled output, output. Okay. Meantime, I forgot to write this I mentioned the reference point to be R of t, while this controlled output is usually represented as C of t. So we will be using in our course, we will be using these two functions. This R of t for the set point, and C of t for the controlled output. Okay. Now, so the forward path is, what do you mean by forward path? It is the transmission path. Transmission of what? Transmission of the signal from this point to this. So it is a transmission path from the summing point to the controlled output. So if one moves from this side, from the summing point, this is your summing point. If then the signal moves to the feed forward, then to the plant, then to the controlled. So this path we call as the forward path. Then another term is feedback path. Feedback path. Now, that is also defined as the transmission path from the controlled output back to what? Back to the summing point. Okay, so you can understand from the figure. So it is the transmission path. Here also, why it is called as a transmission path? Some signal is transmitting from this side to the summing point. So it is the path from the controlled output to the summing point, and that is your feedback path. So feed forward path is summing point to the controlled output, while feedback is control output to the summing point. Okay. Okay. Now next is next portion is just find out. Let's try to find out the transfer function of a closed loop system. Okay, of a closed loop system. So before that, you need to find out, you need to have an idea about the transfer function of a open loop system. Now these are two blocks. Okay, now when you are to find out, so this will be having some function, say g1, and let it be g2. What's the meaning of that? This is equivalent to gain in an amplifier. So right, this output and this input, that is a desired value, becomes an input based on some function of the controller. Okay, you have studied as the network function in a network, which actually controls the output, how the output to be for a desired input. Similarly, the input coming over here has to be in the form of this controlled output due to this function g2. So combining these together, we can have a say we can have the open loop block as say this is your R of t, as I mentioned earlier, and this is C of t, and I'm calling this as G of t. Okay, now in order to find out transfer function, what is transfer function again? So transfer function, as you have been you have studied in your signals and system, the transfer function is nothing but it is the Laplace transform of output to the Laplace transform of the input, provided the initial condition is 0. That means this is, say for example, if y of t and x of t is, so this will be y of x by x of s, as the initial condition is equal to 0, right? Now, so that means this particular block has to be converted to S domain. This is T domain, so that the S domain block will be, this will be, if it is R of t, then this will be capital R of S. This is how Laplace transform is represented, right? So if that is the case, what about Z of t? Z of t will be capital Z of S. Then so what will be G of t? G of t will be G of S. So this G of S we call as what? What is this? What is this path called? This path is the transmission path from the summing point to the controlled output, and that we call as the forward path. So this is equivalent to gain, therefore we call this as the forward path gain. Okay, is it clear? Now, keeping this in mind, you can have an S domain, or you can have a block diagram of a closed loop system in S domain. So you may just try. So okay, now you can combine these together. So this is G1, let us call this as G2. As in this case, you combine these together so that you get what? G of S. Okay, then this is the so here you have your R of R of S there. Okay, sorry, you have your R of S here. Now what is the difference between the open loop and closed loop? There is a feedback, and the feedback comes to the summing point. You don't have any summing point here. So here I'm bringing that summing point. One of the input is R of S. So it is here it is R of t. That means it has to be converted to S domain. So this is R of S, and this is G of S, and that results in what? Results in C of S. Instead of C of t, it is C of S. And then next one is you have a what is this called? This is called as the feedback path, and the feedback path will also be having a gain, right? And let us call that as small h or h of t. So if that is the case, then what will be its S domain? That is, then S domain will be h of s. Okay, so this is again similar to a gain we call as the feedback gain, or it is this gain which actually determines how much of the output has to be taken for the comparison at the error detector. Okay, so how much of the output is to be taken to compare with the set point is determined by this function h of t. So you will be having an S domain for that. So keeping that, so you can just connect this h of s, and this will be connected to z of s. Now what about this? What about the signal? This is small b of t. Okay, this is b of t. So what will be this feedback signal? This will be capital B of s. Okay, then what must be this? Now before going into that, this feedback, I'm assuming that this is minus. So what type of feedback this will be? This will be a negative feedback closed loop system, right? This is a negative feedback closed loop system. And what will be this signal? This signal is error signal. This is r of t plus or minus b, or this error signal is represented by small e of t. Okay, now this will be what? E of s, that is s domain, and E of s will be equal to what? R of s minus B of s, R of s minus B of s, right? Okay, so that's all. That's okay. Now coming to this side, so what is this G of s? G of s is forward path gain in the S domain, or you will say that the C of s by R of s is actually equal to G of s, right? So this is the transfer function. This is the transfer function of an open loop system. So the transfer function is G of s. So this G of s is actually the transfer function of the open loop system. Had it been an open loop system, that is, there is no feedback, then it is an open loop system, then that gain is G of s. But this closed loop system has got an feedback element with h of s. Now when you combine this, the transfer function will not be G of s, it will be something else. That's what we want to find out. Now what is the basic definition of the transfer function? Transfer function is the Laplace transform of the output to the Laplace transform of the input. That is, you are to some way or other, you are to find out the ratio C of s to R of s. Okay, to find out this, we'll start writing equation from the C of s. Now what is the C of s from the block diagram? C of s is equal to G of s times the signal that comes here, right? So this will be G of s into E of s. Now what is E of s? E of s is equal to the error signal. This is R of s minus B of s. This is R of s minus B of s, right? Now what is this B of s? B of s is C of s into H of s, right? So this can be written as G of s into R of s minus, okay, C of s into H of s, right? Okay, now you can bring this C of s terms to this side, so that you will get C of s into 1, this becomes plus 1 plus 1 plus this gs into hs, gs into hs equal to g of s into r of s, right? Now what you need is C of s by R of s. From this you can bring this G of s down. So C of s by G of s is equal to G of s divided by 1 plus Gs Hs. So what is this? This is the transfer function of a closed loop control system. Okay, now this is the case with the negative feedback. Now what happens if it is positive? If it becomes positive, the only chance is it becomes negative. So the transfer function will be G of s by 1 by G of s divided by 1 minus GSHS. So you can do that by yourself to find out the transfer function of a positive feedback control system. This is the transfer function of a, this is the transfer function. Be sure that this is the transfer function of a negative feedback closed loop system. Okay. Okay, now there is a correction here. I will explain once again here. This is, up to this you might have understood, C of s into 1 plus GSHS equal to CSRS, and you need to bring this R of s to here. That is, we need, the transfer function is defined as CS by RS, right? So we need to bring that R of s to here. So this is not C of s by G of s, this is C of s divided by R of s. Okay, so that is the transfer function that is given by GS by 1 plus GSHS, and that is the transfer function of a negative feedback closed loop system. Okay, now coming to this point, this is actually the transfer function of a open loop system, and you might be wondering how I write this expression. This is actually G of s into R of s. Okay, how it happens, how it is multiplied. So you might have, I will just explain, give you an explanation of this. If you have that doubt, I think you may be wondering how it comes. See, whatever system is, we are assuming, or we are actually studying only linear control system. Okay, that is a linear. We are assuming the system to be linear. Now, what must be this G of t? Even though I coined the term as, or said this G of t as a gain, or this is equivalent to gain, from signals and systems course, you have understood that this is your impulse response, right? Now, if this is the impulse response, what is the expression for C of t for a linear system? You have studied this as R of t convolution G of t, right? Now, when you apply Laplace transform, what property you will apply here? You can apply convolution property if you know the Laplace transform of C of t, the Laplace transform of R of t, and Laplace transform of G of t. That, because of this reason, we are converting this time domain to S domain, so that you have C of s, G of s, and R of s. And what is this? The applying the Laplace transform, you can write this convolution as simply the product of the individual functions, right? So this will be R of s into G of s, and for details you may refer my previous notes on signals and system. So from this you got this. So from this you can find C of s by R of s to be G of s. Okay, so this forms the basis of this finding of the transfer function, and you may find out the so I have only found out the transfer function of a negative feedback control system, and you may find out the control of the transfer function of a positive feedback control system by putting a plus sign, so that what's going to be the difference? Here you are going to have R of s plus B of s. Using the same procedure, arrive at the transfer function of a positive feedback system, and do it and post it today itself in the Google Classroom. Okay.